Okay, I just got word that we have permission from the FAA and Homeland Security to turn off our gravity switch today. And so that is important. If I don't clear this with the FAA, we might have an airliner fly over, and if gravity goes off for them, it could result in catastrophe. So they are cleared, and we are going to turn off gravity. Now, if I turned our gravity switch off for the whole room, then when I turn it back on, computers might fall and break, and people might get hurt. And so I have it rigged up so that it only turns gravity off above this platform here. And on that platform, I've placed a baseball, which is currently taped to the platform. Because what we want to do is predict what's going to happen when I turn gravity off, and then I'll remove the tape and we'll see what's going to happen. So when we turn gravity off, what's the baseball going to do? What are all the possibilities? It could, well, I'll picture here. So there's the platform it's sitting on. And so one possibility would be it's just going to stay there. That certainly seems a reasonable thing to come up with. Another one would be it's going to go up, or it might go off to one side or the other, or you might think it's going to go in between those. And so think about what you think it's going to do. So for just staying at rest, that seems to be a possibility. The sum of the forces on the baseball right now are 0 and it's at rest. And if we turn gravity off, do the sum of the forces stay 0? Not an easy question to answer, because the question is what happens to the normal force. So if the gravity goes off, does the normal force instantly go to 0? Or is it there for a little bit, maybe launching the ball up? And imagine if it was a bowling ball and a trampoline and we turned gravity off, the trampoline would be bent, would be stretched, and it would certainly launch the bowling ball up. The question is, how quickly does it go to 0, and is that material flexible enough to launch it? So it's possible that would make it go up, but maybe not noticeable. As far as just staying at rest, we might want to think a little bit more carefully about that. Is it really at rest? Are we at rest? And the answer to that is no. We're on a rotating Earth. And so let's draw the Earth, and there's the North Pole, and we know the Earth is rotating counterclockwise. Make it a little easier, let's put the platform and the ball on the equator. And so we know the path the ball is currently taking is a circular path. And for it to be in a circular path, we need a force directed toward the center to cause that, and it's gravity. At least a tiny part of the gravity causes this small acceleration due to this going in the circle. But if we turn gravity off, there is no force directed toward the center, and the ball would go in a straight line. Now that seems to indicate maybe it's going sideways, but we still rotate in a circle. And so we stay on the Earth, and the ball goes off like that, so that's going to make it look like it goes up. And so from either argument, it looks like the ball should go up. And so let's turn it off. I always keep it locked so we don't have anybody turning gravity off unauthorized. Now some people think this is just a switch bolted to the wall and doesn't really do anything. But if you can see, the switch is clearly in the on position now. And there is clearly gravity. So it does work. This is a gravity switch. So let's turn it off. Move the lock. Here we go. And that's what it sounds like when you turn off gravity. I'm sure most of you know that. So now we will remove the tape and see what happens. Holy cow, we were right. It does go up. I don't want to lose this. This was autographed by a former student of mine. So I'll bring it back down. But just to show you, this does work. Gravity is off over the platform, and the ball rises into the air, just like we predicted. Uh-oh. What is that? Oh, it's just a couple of balls going over a pulley. Oh, wow. But if we did turn gravity off, something like that would happen. You could figure out how fast it would go. At least at first, it's not quite linear. I had a student do that once. It came out to about 28 centimeters per second. You could check me on that.